Hi, welcome everyone. Today at Eindhoven Innovation Café. It's not really crowded today, but I think that's due to the really good weather. So hopefully we have some viewers at home. But nevertheless, we have a very interesting speaker tonight, Dannie van Osch of the company Vertoro. And he's going to talk about their invention, Goldilocks. Dannie, the stage is all yours.
After this brief introduction. So, as I said, I will tell you a little bit more about crude lignin oil, a sustainable alternative for fossil oil. Before that, I really want to go into depth. I want to start at where we see their problem is. And we all saw probably last week and maybe even the week before, I already saw it coming at least. We saw some problems with the rivers in Duitsland or in Germany, Belgium, and also in the Netherlands. And especially this graph or this figure that I'm showing now is a resemblance of where the problems are. And it's a very nice picture which shows I don't believe in global warming. And you see that the water is coming and rising on it. And is the rise in the water only due to global warming, to climate change? We don't know. But what we do know is that we have to stop using fossil oil and that we have to find another alternative. And that's where we also come in. But before that, I want to show you a little bit more. Because what does the public think? Does the public think that climate change, global warming is the problems with the flooding? Well, when you look at the articles in the New York Times, The Guardian, and even NBC News, you see that a lot of scientists, but also, for example, Angela Merkel, thinks that the problem with the flooding is caused to climate change. And climate change is really upon us. And then the question, of course, is it a new thing? Is it something we could have expected already? And actually already in the 1980s, there were articles of in the 1980s, there were reports from Shell and ExxonMobil to large fossil-based oil companies that already reported on that there could be issues in the future related to the CO2 output of these companies. For example, Shell analysts warned about the disappearance of specific ecosystems or habitat destruction, runoff, destructive floods, and inundation of low-lying farmland, and said that new resources of freshwater would be required, while Exxon said and warned for potentially catastrophic events that must be considered. And they also made a very nice graph, and in the graph you actually see the atmospheric carbon dioxide in ppm, so the concentration level, and also the average temperature increase that will occur. And you see that over the years, there's a very nice correlation, and it shows that the more CO2 is emitted in the air, the more average temperature rises, and all, of course, the things that will happen and occur together with it. And we at Vertoro, we see ourselves as a small company, a small oil company that wants to do it differently. And we want to change fast. And the big advantage of the oil that we make is that it's 100% green and 100% sustainable. And as I said, we want to go fast. And we think actually that with the assets that are used now, that's not a problem. It's okay that these assets are even there already, because we can use these assets and quickly transform them from fossil oil to green oil. What we do think is the problem, of course, is then the fossil world, because we extract something from below the surface of the earth. We use it, for example, as a petrol or material. We burn this, and during this burning, the CO2 is emitted. And as I showed 2 slides ago, this CO2 emittance enhances the temperature on the earth, causing the climate change. And what we actually see is that there's more than enough sustainable inputs, and they're abundantly available. Imagine now that the sawdust would be used for making, for example, a fuel, or, for example, making a material. And all this wheat straw, imagine that we would use this and see it like this. You have a tree, you use the material of this tree, preferably even the waste material that's now already burned. You make a material of it. And of course, this will also emit CO2. But as we ensure that there are more trees that can emit the CO2, will uptake the same CO2 that we already emitted. And this is what we call then cyclic. We will come in a cyclic transformation, and all the CO2 that we emit can be absorbed again by a tree. What we see actually is also that the fossil world doesn't like solids as an input. What we saw on the previous slide is that the solids, or say the lignocellulosic biomass, the wheat straw, it's all a solid material, while crude oil is a liquid. And especially the fossil world is not used to working with this. And this is where we come in, because we can convert this residual biomass to what we call oil, bio-oil, also known under a trademark name now, Goldilocks. So what we basically do, we take this residual biomass, we convert it to oil. It can be shipped via existing infrastructure, and then it can be used in the existing assets that are already there. And this is where we really see the value. Imagine, for example, that all the fossil oil that is used at this moment, in a few years, we can transform this or use instead of this 20% of our green oil, a green oil that is CO2 neutral and prepared only from bio-based alternatives. And now I see you thinking, of course, we talked first about climate change, then about the fossil oil, then how we can transform to our crude lignin oil. But how do we actually make this crude lignin oil? And we always compare it to making espresso. And we put some parameters here, what are normally, let's say, in a chemical reactor engineering of the chemical industry are, let's say, process conditions. So a solvent, feedstock, temperature, product, and the residue. Consider now that we are going to make a good cup of espresso. So your solvent is water, your feedstock is coffee beans, temperature 90 to 95 degrees Celsius. Your product is a very good espresso, and your residue will be coffee grounds. What we do is basically the same. We use as a solvent methanol, preferably even bio-based green methanol. As a feedstock, we use sawdust. We use a slightly more elevated temperature, 180 degrees to 200 degrees Celsius. What is our product then? The bio-oil. And what is our residue? Cellulose. And cellulose is actually something you already all know. For example, if you wake up, you take your newspaper and you start reading, this is printed on cellulose. This is, for example, also then a market that we are looking at. So we can use existing technologies or existing assets that are already there. It's a very simple technology comparable to making espresso. And it's a 100% bio-based and CO2 neutral alternative. This is a game changer, people. And I want to show you this also in a technical animation, because of course, one picture says more than 1,000 words. And I hope this animation shows a little bit more how our technique works. Now I have to.
How can they produce over 200 billion tons of biomass each year, a significant amount of which ends up in residual streams of existing operations, such as sawdust, coffee grounds, and agricultural waste. Materials of seemingly low value, but with high potential. These could be a perfect replacement for oil. In order to get there, we need to separate this biomass into its three main components: cellulose, lignin, and hemicellulose that binds these two together. We have developed a process to do just that. We break the hemicellulose bonds with an acid and turn these into sugars. Next, we separate the three components through a process of filtration and extraction using solvents. This results in three valuable platforms: ready-to-use cellulose for new paper and bioethanol factories, sugars that can be used for food, feed, and chemical applications, and a liquid lignin that can be tailored to specific fuel, chemical, and material applications. And that's how residual biomass can bring us one step closer to an oil-free world.
Yes, and I hope the animation showed you a little bit more about what we do. And I want to also go a little bit more into depth even, and I want to show you for that a research development and technology overview, because it was hard to grasp what the specific background of the people would be. I want to go a little bit more into depth, and then I will go a little bit more out of depth and show you some examples of what we already did and how we see the future for this. So when the company started, it was all about lignin itself. So we used lignin, which is a waste material, for example, from the bioethanol industry and also from the paper industry. We did the so-called thermal syntholysis process and filtration, which is basically what we said also during the making espresso. You take the solid component, you put ethanol with it, you put ethanol through it, you get your oil, and you get a solid residue. This is basically what you do then. And then you get your crude lignin oil. Recently, we decided to actually start from lignocellulosic biomass, preferably, as I said, waste material. And we're also working together with partners, for example, in the Netherlands, to find this waste residue. And I can say you there's a lot. Think of, for example, grass that you use, for example, at home when you do your garden. We can use sawdust that is commonly available all in the Netherlands. Or we can use, for example, timberwood that is not used anymore. And all this combination we can throw in a reactor and use them, for example. So we use this lignocellulosic biomass, and as I said, we get three different streams. We get our crude lignin oil, we get C5 sugars that we can use, for example, as a feed, also for animals, for example, and we get our cellulose that we can use as bioethanol or as paper production. But as our main market and our main focus is this green bio, or as we say, our green crude lignin oil. And as you can see, we're working on a lot of different things. For example, we're working on marine fuel, and that will be our first market that will go commercial. We're working on polyurethanes, and maybe polyurethanes is not something that is very familiar to you. But think, for example, about the car that you're sitting in. The foam that is inside your chair, it's a polyurethane. Think, for example, about phenolic resins. And phenolic resins is probably also not known to you. But think then, for example, about fake leather, because fake leather is made out of this phenolic resins. And in the end, all we also want to do is more making chemicals. And for that, we want to use, for example, the existing infrastructure of the oil industry. So we want to use the fluid catalytic crackers. And imagine that we can do this, that within now, let's say within 2 years, we can do 10% replace 10% of the fossil oil. Imagine in 2 years, we can do 20%. Imagine in 10 years, we can do 50%. Imagine what the impact can be that we can change this. And probably already clear to you is the different markets where we want to go. And the different markets where we see that, and we call the so-called, or we use the so-called value pyramid for this, we first want to go for the energy market. It's a huge market, but the margins for profit are very small for that. The second market where we want to go, and it also takes us a little bit more work also, is the chemicals and materials. A smaller market, but a bigger margin for profits for us. And the final market, and that's where we really need a lot of more effort to work on, is the specialties market. A lot of margin, a lot of money to earn. And what we think is that we all need these markets. And here we also look again back to the fossil oil industry. The fossil oil industry has a so-called 90-10 margin. 90% of them, what they make, is, for example, for the energy market, that's only 10% of the value. While the other 10% that they produce is actually 90% of the value that they got. And this is how we also see ourselves as Vertoro. So as I said, the first market that we want to approach is actually fuels. And probably also already saw before that if you go, for example, for fossil oil, it's a very dark liquid. And we actually have the same. And this is where I want to show, and also, for example, already the things that we send out. This is, for example, on the lab. Then our crude lignin oil makes it also a little bit more visible. And we want to use this immediately, for example, for a marine fuel. So imagine all these big ships, for example, the ship that was struck or struck in the Suez Canal. Imagine that our oil is used for that ship. And these are then the first containers that we made and that are now currently already being tested for these engines, or in these engines, I should say. Other things that we're working on is, for example, lignin-based polyurethanes. And this is really then the material application. As I said, we first want to go for fuels, first market, low impact on our profit, but the first market we want to go for. The second market is material application, a little bit more profit. And one of the things where we really see future is on lignin-based polyurethanes. We're working here, for example, also together with other companies such as Vito, a Belgian research institute, and Indresmat, a Spanish startup. And we made these window frames. Imagine now that all your window frames that are now made from metal, which is a huge CO2 emitter, can be replaced by our lignin-based polyurethanes. Imagine already the impact that this has. And also other things that we're working on is, for example, extrusion. And also blending our lignin with PLA, which is a commonly used plastic. And there I want to show you also another movie to show you how this, for example, works. So we see here that we're collecting our lignin sample that is mixed with PLA, polylactic acid. We see here already some examples that we made, for example, 2%, 5%, 10%, 20%, and 40%. So we're collecting our sample, and this is via injection molding, a very commonly used technique in the chemical industry. Also there, we just want to use techniques that are already there. Now we're going to extrude it, and we're going to make the samples as we see them on the right. And as I said, it's a very common and simple technique, and it's already a huge advantage for us that we have proven that this is possible. So we're working now towards our final product. And this young man is making this for us. Now we will open it, and then you can see our final product. And this is already what we can make. And this is now, for example, something that we are testing on the properties of the material. Does our lignin addition enhance the properties, or are the properties worse? So we're testing this at the moment. And who knows, maybe in 2-3 years, I can tell you a little bit more. I can already maybe show you some really applications that we already tested on, also on a larger scale. As I said, we also want to work to specialties and chemicals. And this is something where we're working now very hard on the low level, so really on a research and development level. And also here, we hope to show you a little bit more in, let's say, 2 years. So the company started already back in 2017. We are working now on a pilot plant scale, which is already after 4 years that we started the company, which is it's quite fast from a chemical point of view. Next year, we'll go to our demo plant phase, and then we will prepare 1 kiloton per year. And then we're in the so-called technology readiness level of 8. And 1 year later, maybe 2 years later, we want to go for first commercial scale. We're already very positive and sure that the demo plant will be a great success. And in our commercial plant, we want to go for 100 kiloton. And from that point on, we also want to license our technology. And we hope that, for example, large fossil-based companies, for example, a Shell or a Dow, is also interested in our oil by then. And we think in 2030 that we will make 1 million of tons of our crude lignin oil. And this is let's say a small introduction of the company. I can tell you a little bit more. And if you have any questions, don't hesitate to ask them. And if you would end up with questions, for example, in a later stage, don't hesitate to send me an email, and I will try to answer it as good as possible.
Talk. Are there any questions? Yes,
Hi, thanks for taking my question. What I'm curious about is if we use this bio oil to replace crude oil, that doesn't really make anything more sustainable, right? I mean, it's nice that we can use these waste products and reduce the total amount of waste, but just replacing crude oil with bio oil seems like it would produce the same amount of CO2 and the same amount of waste, and I don't know, maybe even transport costs and things like that. So what then are the advantages of bio-oil compared to crude oil?
Yeah, that's a very good point, and I totally agree with you. If you just take this oil and don't take care of, let's say, the remaining parts and really the sustainability about this aspect, I totally agree with you. But we should look a little bit more, let's say, in the technology. The big advantage now by using this bio-oil is you take your wood, your waste wood, you use you make your, let's say, crude lignin oil of it, your big bio-oil, and of course, as you say, it emits CO2. But what we can do, we can make sure that there are enough trees that can capture the CO2 again. And then based on all the CO2 that is emitted, this can be captured by a tree, and then we can start the whole cycle again. And this is what I said, it's more a cyclical process. While if you think, for example, the oil, now it's in the ground, and it's actually safe there. It doesn't emit any CO2. But because we extract this from the ground and we start using it, then you actually also emit the CO2, and then you come more in a linear environment. And this is really the difference. Imagine now that we can do this. Imagine that we can do it more in a cyclical way. And this is really where we see the future then. Of course, this is also something that we do a lot of research on. We have one person fully dedicated also to sustainability that does life cycle assessments to make sure that our process is 100% CO2 neutral. For example, something that we also choose then is that we don't want to make a lot of, let's say, big plans. We don't want to make one central big plan and say like, okay, this is the plant we're going to use. No, we want to do it more strategic. Imagine now there's a lot of bio-waste, for example, next to a timber production company. Then we would build a plant there and also there distribute the oil already. Or, for example, we do it in the big harbor, for example, in Rotterdam, because if you do it there, we can immediately distribute it all over the ships that already use it. Imagine now that we build a plant in the Rotterdam harbor. It goes via a pipe and it goes immediately to a marine fuel ship that uses this for shipping. And this is really something that we're thinking about and then also doing a lot of research on.
Did this answer your question?
Yeah, thank you for the elaborate answer.
Yeah, thank you for the nice question.
Are there any other questions? Yeah.
Thank you. And then I have two questions. One of them is about efficiency. And my question is, for example, with a specific fuel, we can drive 100 kilometers with 10 liter. 10
Yes.
liter equal to the 100 kilometers. And in the other hand, 10 liter is equal to around 17 euros. So can you make a little bit a comparison with efficiency and cost versus to the classical fuel?
Yes, that's a very interesting question and also a very good one, I must say. I cannot go really elaborate more, let's say, on the gigajoules per let's say, ton. That's a little bit outside of my field. What I can tell you, there are, of course, a few, let's say, shipping companies that are, let's say, specialists in shipping fuels. One of them is, for example, Maastricht, and probably you saw it before, especially there are a lot of containers, for example, that have the name Maastricht on it. And Maastricht made a report for how they see the future in 230 and 250. And they see two routes that they can take. One route is ammonia, so use ammonia for shipping. And the other route that they propose is methanol. The only problem is with methanol, if you use methanol as it is, you still need a lubricant. And the big advantage of what we have is that our lignin oil is based on methanol, and lignin itself works as a lubricant. So as we would say in the Netherlands, we actually kill two flies with one whip. And this is really where also, for example, in Maastricht's future, then they did also our own report, and they showed, for example, also that that if you use something like methanol with lignin, it is a very preferred shipping fuel for the future. And this is also I think the luck of the company, we started at the right moment, at the right time. If we start 2 years before, probably we would not be that lucky that we can expand and grow as fast as we do now. But we started, let's say, 2 years later, we would have missed the boat in this case. Does that answer your question?
Okay, that's enough. Thank you.
Are there any other questions I wanted to ask?
Yeah, thank you for your talk. I was wondering how much waste could you feasibly collect each year?
Yeah, that's also a very interesting question. As I said also during my talk, we're really talking to companies also in the Netherlands that are specialized in this waste. And also here, what we want to do, for example, if we have a plant in the Netherlands, we want to use waste from the Netherlands. But yeah, these are actually big markets. Don't be underestimated about this. For example, also, let's say local governments that, for example, work on trees have a lot of garbage on this. If I'm not mistaken, I think it was something like 70,000 tons only that the government of Rotterdam yearly has as a waste material. And as I said, lignocellulosic biomass is everywhere. There are trees, it's grass, it's even, or lignin is even in coffee grounds. So there are a lot of big markets that are available, because imagine all the coffee grounds that you use for your coffee. Imagine that we start to collect this. Imagine that we take out the lignin of this and we make our lignin oil of this. So the markets are huge. The biggest thing that we have to check now is which markets are, let's say, are very interesting for us to use now, and which can we really use. Because in the end, it should also make sense, of course. We can start from two different parts. So as I said, for example, then lignin sources, for example, then indeed coffee grounds, or from lignocellulosic biomass. What we prefer also from a sustainability point of view is really lignocellulosic biomass. Why? Simply because we can use then 100% of our products. We make then our good lignin oil, which we can use 100%. We make the cellulose, which is already used in a lot of different markets. Think about paper, bioethanol, or nanocellulose. And we make C5 sugars, and we all eat even C5 sugars. So then we would be able to have 100% of our products that can be used by the market. And really, from a sustainability point of view, this is also a goal that we set ourselves.
Yeah, just a follow-up. I'm not an expert, but the municipalities, you know, in the Netherlands, we all have our green bins. I think everybody knows them, but I throw my grass in it and my coffee, but also my fruit, vegetables, fish, meat. You know, don't you have to separate that? Is that easy to separate? Doesn't it get contaminated? Or that's what I was wondering with the feasibility, because asking everybody to separate their coffee, their grass, everything, that's going to be a big ask, I think. Also, the municipalities, the people doing
that's a good follow-up. First of all, I think in the beginning we will start more, let's say, from industrial streams. As I said, for example, timber factories that have waste. Really, let's say the big companies that can supply this. And I think also here, as people, we have to make a transition. That's the same also as I say. Let's say the electric car is not the only solution for future transport, and the same also for our oil. It's one of the solutions. For example, what you also have to do is, for example, things that we have to start doing is recycling of plastic. And now I even separate my plastic, but I put everything in one bag. So there are 3, 4, maybe 10 different types of plastic in there. And we have to find good ways to separate this. And this will also in the end happen with all the lignin sources. In the end, we have to rethink the way that we recycle things. And it cannot be that we throw everything in one bag and then it's done. How are we going to do that? I don't have an answer yet. And I think we're lucky enough that we still have enough industrial streams first. But at least what I think is that in the future, we have to rethink how we're going to do all these things. And then how are we going to recycle and also make sure that we have all these streams separately. Does that answer your question?
Yeah, thank you indeed. Yeah, but I was just wondering indeed if you how must I say, when you thought you would hit your limit, so to speak. But yeah, no, thank you very much. Clear answer.
The estimations that we show now is that we can easily go till 230, and after 230 maybe we have to rethink our strategies. But I think also let's say as you also say, the municipal and also the governments have to rethink their strategy. So this is something that will happen anyway.
Yeah, indeed. Thank you very much.
Thank you for the very nice questions.
In the meantime, I do have a question. Maybe turn your presentation off so we can see you on the screen.
That's no problem.
Is there another question? Oh, yeah.
Hi, my name is Maria and I have a little question. It's kind of connected to the previous speaker. What do you think? Is society ready for the transition to the green power? And what are the obstacles that you as a green company can meet on this way?
Yeah, that's a very interesting question. I think a little bit out of my field. What I think is yes, we're ready for it, but are we all ready? I don't think yet. But when I look, for example, at the let's say the millennials, I see a lot of people that are really thinking about the climate change and how we can tackle this, and also how we can battle this. So I think there are a lot of young people that are really ready for this, and I see more and more changes. Where I see the biggest hurdle is that, especially in the beginning, our prices will be more expensive than, let's say, the fossil oil. And the question then is, are people willing to pay for that? And if people are willing to pay for that, problem will solve itself. If people are not willing to pay for that, we should maybe lower our prices, but then we have the problem, of course, that we cannot maybe have enough profit anymore. So these are the problems then that can occur. And I think it's really a shift. And when I look at the last 3-4 years, I see a lot of young people, I see a lot of old people, I see a lot of people anyway that are really saying, like, we have to change. And as soon as more people are aware that we have to change, I think this change will be inevitable and it will come.
Thank you.
Thank you.
Is there any other question? No? Then I have a last question for you. Can you tell us something about the background? Because you have a very interesting background.
Yeah. I wanted to say that during the presentation. I forgot that. So indeed, the background that you see now, I'll show a little bit more by going a little bit more to the left. This is actually the pilot plant that we are using now. And this is, let's say, where the magic happens every day. This is where we make our crude lignin oil. So this is where we start with a solid material. And this is where we transform the solid material to the bio-oil. And then hopefully this bio-oil will be used as soon as possible in the fossil oil industry. Thank you.
For your interesting presentation. Unfortunately, joining us from a distance,
yes.
But everyone here in the room, I want to invite you to join us for drinks, not in the bar today, but in our courtyard terrace, if you're interested. And next week, we talk about innovation in social housing. So thank you, Dannie.
Yeah, thank you for having me, and I hope it was very interesting. And if there are more questions, don't hesitate to send me an email.
Thank you.
Thank you. See you.